All right, I guess we'll get started. So last week we talked about variables and conditionals, which should have just been a recap for everybody involved, right? You guys have all had intro to programming already. You should all know what a variable is by this point. So really it was just talking more about the variable syntax inside JavaScript. We talked about, kind of the underlying principle of what a variable is, that it's basically a human readable label that points to a memory address in your RAM. We talked about that it makes things a little bit more, clear when you're trying to read somebody's program. We wrote some variables. The first one we wrote was a global variable, and we set its value to hello world. We talked a little bit about data types and the fact that JavaScript's data types are fairly simplistic. You don't get quite into the complexity of like car and string and doubles and floats and unsigned ints and stuff like that. Unfortunately, that's not available to you, or maybe fortunately, depending on how you look at it. In JavaScript, you only have this small subset of data types available to you, and that is number, which will cover all floats, all decimals, all doubles, unsigned integers, signed integers, doesn't matter, that's what it covers. String, if you want to create a character, that's just a single letter in a string, right? Boolean, which is classic across any language. Arrays, and then objects as well, right? And these are your primitive data types that you have available to you inside JavaScript. Then we created some implicit variables. We talked about the fact that JavaScript doesn't use explicit data typing. There are transpiled language like TypeScript, for example, that will allow you to use data types, but JavaScript, vanilla JavaScript, does not use data types because it's a duck type language, right? So remember we talked about that. If it walks like a duck and quacks like a duck, it must be a duck, right? The whole idea, for example, full name, because Sean McKinnon is a string, then full name's data type is a string. Because age is 39, and that's a number, then age is a number. It's called implicit data typing. All right, we talked about variable scope. The idea in JavaScript is there's 4 different scopes that you have available to you. Sorry, 3 different scopes. There's global scope, which means it's available to you throughout your application. The way that implies, though, is like if you were to basically create this variable inside the function body or any function body, you can still access that variable outside of the function, okay? Whereas if it's functional scoped, meaning you've defined your variable using the keyword var, then it's only within the scope of the function that that variable is available to you. Now that also includes blocks that are children inside that block, right? Block scope, same idea. If you've defined your variable with either let or const, it is only available to you within the block, right? Now that includes things like if conditions, while loops, for loops, anything with a set of curly braces, basically. Well, also case statements, right? Because they also have a block. They're just not, they're not wrapped inside curly braces. So the only difference between let and const are not mutable, right? They stand for constant. You guys have used constants, I'm sure, before. You can't mutate the value once it's been set, whereas lets are mutable. You can mutate their value at any point. Which should all, this scoping applies to a lot of languages. It's just usually done implicitly. You don't usually have a modifier that sets it. That's more kind of like when you're working with classes and you have private, protected, and public. That's what it feels more like, but don't confuse it with that because that's not what it is. It's definitely different. Because they're all public. All right. What else did we do? Talked about conditionals, the classic comparison operators such as equals, equals, and strict equals, which is 3 equals signs. Because JavaScript is a loose-based language, double equal signs and triple equal signs are different. Double equal signs will evaluate the value. Basically, it will compare 2 values and see if they're the same, which means it doesn't really care if they're wrapped in a string or not. It will just evaluate them and say, yeah, this is true, right? Whereas strict equals actually takes a look at the data type as well, the implied data type, and it says, nope, 5 is not equal to the number 5 because they're not the same data type, even though they are the same value. It is better practice, it is best practice, I should say, to use triple equal signs and forget the double equal sign altogether. Okay? Just pretend it doesn't exist. If you use vanilla JavaScript in strict mode in your IDE, and some of the IDEs you guys might be using may already have strict mode turned on, if you use it in strict mode, it deeply frowns against double equal signs or not equal sign. It definitely wants you to use the triple equals. We talked about greater than and less than. All these comparison operators shouldn't be new. They're in every language that I can think of. And then we talked a little bit about the two logical operators, and or, right? We didn't talk about XOR. It's a little bit out of the scope of this class. But and basically means that the left expression, the right expression must both be true in order for the whole thing to evaluate as true. And or says the left expression either has to be true or false, and the right expression either has to be true or false, but one of the two have to be true for the whole expression to be evaluated as true. Again, not new, right? Just really learning more syntax type stuff inside JavaScript. We covered if-else conditions, which I mean even syntactically shouldn't be new because that's how you write an if condition in almost every single language I've ever touched, except for maybe Ruby because you don't use curly braces in Ruby. But other than that, every other language, it's that. What else? Talked about switch statements. Big gotcha with switch statements is that break. That can throw people off because if we don't have the break, the case will evaluate to the next case. And it'll keep evaluating as long as there's no break or a return or something to basically exit outside of the switch. As soon as you put a break and the case evaluates as true, then it will execute the code inside and that break will basically exit out of the switch statement. However, you can use that to your advantage if you're trying to build something or you're trying to modify something based on several different conditions. You can use the switch to that kind of approach. Sometimes switches can be a lot more human readable when it comes to dealing with conditional statements than versus, say, an if condition. And now with the new engine that's built into Chrome and Firefox as well, there's no efficiency hit between switches and if conditionals. So in case you've read that, oh, well, if conditionals are better because, there's an efficiency hit, there's a benchmark hit when it comes to switch statements, that's no longer true. All right. Rest of you are probably like, I don't care. All right, that's totally fine. Use what you want. And then we talked about my favorite shorthand, the ternary. Ternaries are great. Really fantastic when you're trying to do toggle logic. They're very clear. They're pretty easy to read. Ternaries can become extremely unclear if you try to use nested ternaries. And you keep kind of nesting, because that's what you can do. Inside these spots here goes an expression, whatever expression you want. It can be a function call. You can do whatever you want. However, if you start nesting in a ternary in those areas, then the readability starts to become a little bit more obscure, and it gets harder to read. Use ternaries for very basic returns. That's what I use them for. If I'm just trying to return a response, I'll use a ternary. I generally only really use them in toggles, mostly. And that's it. Hard to believe that was like a 2-hour lesson that we just covered in 10 minutes. Flat. Not too bad. Hey, let's do that with arrays today. Cover those in 10 minutes flat, right? Then we'll all go home. Sounds good. I could use an early beer. All right. So if you haven't picked it up yet, this is Blackboard. Hopefully you've signed into it at some point. Every week these will come open, usually an hour before class. I think I was a little late today. But usually an hour before class they will become available. However, if you're subscribed to my GitHub repo, you'll notice them in advance because I usually post them by Sunday. I'll post up the lesson to GitHub, so you can always preview it on Sunday. That being said, I teach it Monday, and it may change between Monday and Thursday. Because as people point out mistakes, I'll modify them and then repush, which means that code base could definitely change between the Monday and the Thursday. If you go into week 2, you'll see the link for module files there. If you click on module files, it'll take you to the GitHub link. And there's wonderful GitHub with the cloner download and so on and so forth. And yeah, you could download that whole file. This is going to change how I'm doing this. I'm going to make each module its own separate repo, which means each week you'll have to pull down that repo. The only reason being is because we're going to be modifying the main JS, and I'm not giving you guys permission to push your code to my repo. So it causes an issue if you try to pull again. You'd wind up overwriting your main JS file every time, which can be very frustrating after you put all that effort into it. But I am going to show you how to actually pull code down from GitHub, even though I'm sure you guys have done it, right? You guys pushed and pulled code. No? Cool. I'm going to teach this a little differently. We're not going to do it from the command line. Everybody does that. Every teacher teaches a very small snippet of stuff you can do from the command line. I'm going to teach you how to use a GUI because it can make your life a lot easier. The other cool thing about the GUIs is it actually shows your history a lot better when it comes to working with your Git. I just find them more powerful. Plus, hopefully it will push you to do more things with Git instead of just the basic push-pull. But yeah, so let's talk about that. So we're going to utilize an application called Github Desktop. Now, if you already have Git experience and you're comfortable with the command line and you don't feel like using a desktop GUI, then feel free to use the command line. That's totally fine. I'm not telling you what to do here. You use whatever the hell you want to use. You want to use Tower if you're on Mac, go for it. If you want to use source tree, go for it. I don't care. Because you're not in that window of somebody who's learning it, right? You're somebody who's obviously experienced with it. So for those of you that are learning, though, this is a great tool. It's open source. It's free. It's not opinionated. It's just great. And it works on Windows and it works on Mac. If you're running Linux, yeah, you're going to need Git Kraken. That would be the only one I can think of. Or source tree. I think source tree will run on Linux, too. But other than that, how many of you are actually using Linux in here? Nobody? Must be the other class. I have some student using Linux. But if you're not using Linux, you're just using Mac or Windows, feel free to click that wonderful download button for me. And it should take, depending on how wonderful Jordan's internet is today, should take about 2 or 3 minutes to just come through. While that's happening, I'll quickly explain what Git is. Git isn't necessarily GitHub. GitHub is a version of Git. Okay, Git is called it's a version control system, essentially. I don't know what SVN actually stands for, but it's version control system. Basically, what it allows you to do is you can write out some code, right? Not even necessarily code. You can write out text, you can do a graphic, you can literally do whatever you want. You create like a series, like a project of files or single file or whatever you want, and you take that thing you've built, we'll call it a project. You take your project and you push it to your Git repo. Then your Git repo keeps track of that. When you make a change, it only applies the change and saves just the change of the file. So if you're working in a binary file, it'll save just the binary difference between the original file and your new file. If you're working in a text file, it will just save those text changes. For you guys who are programmers, it will save your code changes. So it will only keep track of the code changes between your one version that you started with and the next version. Okay? Every time you do another push, again, you wind up with another little bit of code change. And you can actually go back through your history and revert your code back to an original state, which is fantastic. Because before version control systems, people would literally copy and paste their code and create duplicates of their code constantly. Just big, massive duplicates, right? Like, so if you're building a piece of software that's like a few gigs in size, you can imagine how terrible that's going to be to your hard drive when you're just storing massive amounts of code changes because you're literally copying and pasting the whole system, the whole project every single time. Git prevents that, stops that, because it only stores the physical change that you've made, right? Which is usually minimal, like maybe, a few hundred kilobytes, might be a couple of megs. Nothing too big, nothing too drastic, unless you had like a library or something like that. Git also allows you to ignore certain files. Perhaps you're using like a package manager, right? There's no reason for you to commit those files because whoever decides to use your code base can always pull those files themselves using your code manager. Git, and along that same vein, Git also makes sharing your project with other people very simple. It makes it simple also in ensuring that the person you're sharing your code with doesn't damage your code, that they can't affect your code directly and cause it to be, not work anymore. We can use things like branching to keep people on their own separate branches. We can use things like pull requests so that people can review the code before it gets actually committed, things like that. Git is very, very powerful. Now, Git runs locally on your machine, and you can submit to your own local repo, and you never actually need to touch GitHub or Bitbucket or Gitfire or whatever it is that you happen to be using as an online repo. But the benefits to an online repo is the whole reason why you use cloud storage, right? Or why you use a USB stick or something like that. It's so that you have a backup of your stuff, right? That's one of the biggest benefits to using an online repo like GitHub. And you guys as students get free GitHub, right? You actually get a paid version of GitHub Pro, which allows multiple collaborators on it, allows private repos, even though private repos are now a thing. They actually just recently changed that since Microsoft bought them. But it gives you the ability to really use GitHub to the fullest extent, including running your own website right through GitHub. Okay? All right, so hopefully during that your desktop GUI has downloaded. The next step you're going to need to do is actually go to GitHub, because we are going to sign up for an account if you haven't already. And I'm going to sign out. And like I said, this is not an opinion. You don't have to use GitHub if you're personally attached to Gitfire or Bitbucket or something like that. At the end of the day, everything I'm saying isn't new to you anyway, so just ignore me. But for those of you that are learning, I prefer to use GitHub. With your Georgian account, you guys get free paid GitHub, and it makes total sense for you to use GitHub. All right, so if you go through here, you're just going to give it a username. Keep track of that username because you use it to reference to your repos. So don't lose it. Don't just come up with some arbitrary weird word. Come up with a decent username. Give it your student email address, a password that you're going to remember, and then click sign up for GitHub. I'm just going to sign in. That is definitely not my GitHub. I have quite a few different versions or different accounts at this point. All right. Once you've signed up or signed in or whatever it is you're going to do, we're just going to create a new repo. Next week, I will be assigning the first assignment. You'll have till reading week, just after reading week, so basically the start of your next term, which will give you about 5 weeks to complete it. That being said, my assignments are never really that hard. They take about an afternoon to complete, a good solid afternoon, to reach, a 90, about an 80. Take you a day maybe to reach about 100% if you put some effort into it. But that being said, you'll have 5 weeks. However, I find that even giving 5 weeks, I still have people asking me for extensions because they back burner it forever, and the next thing you know, it's 2 days away, and you're jumping on it 2 days away from it. But yeah, so anyways, that'll be assigned next week. So we're going to create a repo for it that you guys can then push your code to, so that you have your code sitting in the repo, and then when it comes time to actually submit your assignment, you'll just give me your repo link. I'll go to your repo and download your code and evaluate it and mark it. All right? So is anybody still signing up? No? Don't be shy. Tell me, because I don't want to move on ahead if you're behind me. All right, cool. So on the left-hand side, you should see a list of repos, which if you're brand new to GitHub, you won't have a list of repos. So you're going to click on the New button to create a new repo. I'm going to click New. And it's going to show your owner and then a slash and then whatever you want this to be. The cool thing is all of you can title your repo the exact same name because you're basically namespacing into your username, right? So it's unique to you. So what I would do is just call it assignment 1. Or maybe, actually, a better name would probably be comp 1073 assignment 01. That would probably be better. Because you should be using Git for everything you do, really. Incidentally, Dropbox is also a version control system. So if you have Dropbox, you're doing something good. Dropbox, actually, when you make a change to a file, it only stores the change. So you can actually even revert back to original versions, up to 30 days, which is kind of neat. You can create a description, but we are going to initialize this repository with a README, so make sure you click that checkbox. And because it's your assignment, I would click private, just to avoid somebody stealing your stuff and submitting it on your behalf under their name. All right? And then don't worry about the git ignore or the license for now. Just click that wonderful create repository. I'll create one too and just delete it. And once you're done, you'll see the name of your repository there inside this README file. Now the README file is written in markup, and you can actually add to it and create a good write-up. Like, for example, if for your assignment you build an application, you want me to know how to use it, you can put the instructions inside your README file. Or in assignment 2 will likely be group work, which means you can put your group number inside the assignment 2, right? So those are things that you have the ability to do with the README file. Cool. So all this is fantastic. Now what the hell did we do with it? All right, I'm going to close that out. I'm going to go back to this link, which you will find under week 2, the module files link. And you're going to see this wonderful green button here that says clone or download. I want you to click on that button. And if yours currently is set to SSH, you need to change it so it's clone with HTTPS. Okay? And then you're going to click the little copy button, or you can just highlight it if you want to run old school. I'm going to click the button. I mean, they put it there. Might as well use it. And then we're going to go into our Github Desktop. So I'll open mine. It's going to look a little different than yours at first. Of course, it opens in a wrong window here. Just give me 1 second just to reset for Monday. Bam. Yep, remove. All right. Yours might not look quite like this because you're brand new to it. It's probably going to ask you to add your GitHub information. So if it wants you to sign in, please do that. Make sure you sign in, add your GitHub information, sign in with your username and password. And once you're all done that, you should have the ability to either create a new repository, add one, or clone one. Now, if you don't see those buttons, that's totally cool because at the very top, I don't know what it looks like in Windows, but in Mac, you have a repository menu, right? Except for that's not what we want. We want file? File. We want file. And under file, you'll see clone repository. So we're going to click clone repository, and it's going to give you 3 options. Now, if it's your GitHub and you're cloning your own repository down, then stay under the github.com, and that's what you would do to pull your assignment down when you guys are ready to do that. But if it's somebody else's repository, click on URL, on the tab that says URL. And I'm assuming you can guess what we're going to paste in there. We're going to paste the link that we cloned, right? So I'm going to paste it in there. I wish I could make this a little bigger. I do apologize, but there's no way to actually scale the screen. So that's where you're going to paste that. Now don't click OK quite yet because you want to choose your path, right? So choose a path where it's easy for you to find your files. Now you guys are all second-year programmers, so navigating File Explorer should be like old hat for you. Shouldn't matter where you put your files, right? You should know how to get to them, okay? If you don't, I recommend taking a Senior Citizens course on how to use your File Explorer. going to go to desktop. I'm going to just put mine on the desktop. Don't put yours on the desktop. Don't clutter your desktop. Be good desktop users. You shouldn't be that person that's got like 600 icons on your desktop like my mother-in-law does. I need to know where my stuff is. It's going to be on my desktop. Right? No, don't put everything on your desktop. All right, when you're done, click clone. Clone! Helps if you aim. Maybe don't wind up and hit it. Now that's cool, you've cloned it, but it's not necessarily down yet. It won't be down until we actually do a pull. So the first step we should do is, you see this wonderful fetch origin? We're just going to fetch origin. What that's going to do is pull any branches I may have available. So this is kind of neat. So I've got this top level repo, right, called comp 1073, right? And immediately when I create my repo, I wind up with a master branch. Okay? It's literally a version of my entire application underneath master. Okay? The cool thing is if I'm collaborating with somebody, I don't want them working on my master. I would rather them work on a branch that they can totally mess up all on their own. That works for me because if their code doesn't work out, I don't have to commit it to my master, right? So I can create sub-branches, right? So I'll say I'm working with a guy named Tom. This is Tom's branch, right? Tom's branch still works off mine. When you click fetch, it actually pulls both these branches down, and so you can see both branches and work from either one of them. That's the idea of it. So anyways, next thing we're going to do is just do a quick pull. If you click on repository, you will see the pull option in there. Just click pull on it. It's going to go boop boop and not show you much information. But if it's done, you should be able to go to the folder where you saved it. I'm going to go to my desktop. Here's my desktop. Sure enough, I have a folder in there called comp 1073-winter 2019. And I have my code. Okay? Yes. Out of curiosity, how many is that new for? GitHub, period. Maybe just a couple? Okay, cool. If you don't want to do that and you're like, I refuse to use GitHub, good luck to you. But you can always just click clone or download and download the zip file. That's totally plausible as well. But I recommend, if you want to get jobs, learn how to use Git and learn how to use GitHub. The industry uses it so much. Everybody does. It's very rare that you'll find somebody who's not using it. Okay, so it's definitely something worth becoming experienced with. All right, cool. Now that we've got that down, we can go ahead and close out these links because we're not going to need them. And we'll go into our file explorer. Can I zoom in? Oh, cool. I wasn't sure if that would work. I know it's still kind of hard to see, right? I do apologize for that. Open up your IDE, whatever IDE is that you're working with. Now I'm working with Sublime, and I know many of you told me that you guys had Jest, so you're working with Sublime as well, likely. Okay? And then just drag that folder directly into Sublime and drop it. And that should spit out all of your folder files there. Now, if you don't see this sidebar, you can actually pull it up using Control-KB. Or if you're on Mac, you can hit Command-KB, and it will pull open. Cool. The last step is you're going to open up, I'm going to just move this over here. You're going to open up a new tab in your browser. You're going to double-click into your comp 1073 folder inside your file explorer. You're going to grab that index file, drag it over to the browser, drop it, and it should open up this cool little menu that I spent so much time designing. You can tell, can't you? It's gorgeous, right? And then just click the Module 2 link, and then click the index.html link. And boom! You should see this wonderful page. I'm going to dock that to the left. I've got my IDE on the right so that I can work on my IDE. I'm going to zoom in a little bit so that it's easier to see. I'll zoom in this side as well. Hello, can you guys read that from way back there? Or does it need to be bigger? Bigger? No? Good? Cool. I hate it when the text gets so big because then I lose so much real estate. It's hard for me to type out really complex things. All right, awesome. So if you haven't guessed already, today we're going to talk about arrays and loops. But before we do that, we're going to do a very, very small little lesson on the basic syntax rules of JavaScript, just because we didn't really touch on it last week. Next time I teach this class, I want to move this to the first week, just because it makes sense. But it's very simple, and most of it you guys already know, just because it applies to other languages as well. Last week we did talk about variable naming, right? You can't use dashes, can't use spaces, can't begin a variable with a number, right? And that's pretty classic in most programming languages. However, in JavaScript, something that we didn't really talk about is you can do this. You can begin it with an underscore. That is totally fine. You can also begin it with a $sign if you want to. Those are both valid variable naming. That's totally fine. Okay? Something to note though, in the world of JavaScript, when you're working with other coders, these things, they mean something. They actually have meaning to people. Often this is used with inside like a plugin or a class or something like that in order to avoid issues with naming collisions. And then this is usually used for the same reason. It's usually just to separate it so that you can do things like this. Right? Does anybody know what the potential problem of that would be if I remove this? Anybody want to take a guess? Yeah, exactly. It's a reserved keyword. Because it's a reserved keyword, it will blow up and JavaScript will freak out and say, sorry, you can't use this. It's a reserved keyword. So we can get around that by either adding an underscore or a $sign in front of it. And then that kind of allows us to use the keyword, right? Cool. So that's one of those. The other one is the semicolon, right? The semicolon is extremely important for terminating the statement. Now, those of you that have been kind of moving your way around JavaScript or have worked with JavaScript before might know that the ES5 and ES6 community is like, we don't need semicolons anymore. Stop using them. That's not entirely true. On the client side, at least, inside the browser, the semicolon can often save problems because the way JavaScript works is it logically moves from this expression and it will keep executing till it hits a semicolon or a logical endpoint, right? So if I have equals 5, JavaScript's like, well, likely, very likely, this is where we're terminating, right? But if on my next line I have dot length, then JavaScript's like, oh, wait, no, you likely want to terminate here instead. And it tries to figure that out. The semicolon makes this a lot more efficient because it says to JavaScript, I'm done. Now move to the next line. Okay? So we're going to use semicolons because it will avoid a lot of hassle, a lot of issues with your code, and make it not so difficult to find where the bug is. All right? The next thing has more to do with the lab that people submitted. I was kind of surprised just because it feels a bit alarming on how many people who don't know the difference between assignment versus comparison. So, what's happening in this expression? Yeah, exactly. I'm assigning 5 to x, right? Okay, so let's change this a little bit. I'm going to use print, though that's not an actual thing. Say, here we go, x equals false, right? Out of curiosity, how many people say this will print hello? How many people say it won't print hello? You're all wrong, it will print hello. The reason why is because this doesn't say, is x equal to 5? What does it say? It says x is equal to 5. Because we're assigning 5 to x. We're basically saying, cool, assign 5 to x. So here's what happens in literally every programming language ever. Okay? 5 will be assigned to x. Then x will get evaluated. And the way programming works is unless x is false, which it isn't anymore, it's now 5. Unless x is false, it will execute the block. Some programming languages, if this is 0, it won't execute because it treats 0 as false. But in JavaScript, this will 100% execute. So how do I fix it? Yeah, exactly. We just use either the triple or the double equals. Now we're doing a comparison. Now we're saying, is x equal to false? Or is x equal to 5? We're asking a question as opposed to making a statement, right? That's the difference between the two. So I'm just making a point of that because, out of 80 labs, there was like 15 of them where they were being assigned. So it was quite a few, and I think it's worthwhile pointing that out. So that's definitely something that should have been covered in your intro to programming. But yeah, so there you go. If you forget, I've got a bit of a write-up here that explains it a little bit more in detail. And then you can also contact me via Slack if you need more help with that particular issue. Last, we saw the comments in the file. We know what the comments look like. I don't think Java's commenting is any different than this. I think it's the same when it comes to multi-line or single line. So it's pretty easy. But basically, comments are code that does not get executed. That's the purpose of a comment. You can use it for, usually you use comments to help explain why you're doing this particular expression, right? Here's my logic. Here's what it's supposed to mean. Eventually, what you guys are goal-oriented towards, what you're trying to achieve, is almost, not none, but almost no comments, because your code should be readable. It should be able to start at the top of the file and read it, just as if you're reading a story or a book or a chapter or whatever. You should be able to read that code line by line and kind of get the gist of what's going on. If you look at our massive system on G-Shift, we have over 10 million lines of code, and it is basically readable. Sometimes it's not. Sometimes we hire a developer who likes to be very meta and do very crazy inception kind of crap, and then doesn't write any comments, so nobody has a clue what the hell's going on, right? That's the time when you need to write comments. If you're going to get really super meta and super computer sciencey and do some kind of quantum mechanic type crap, then write a damn comment. But if you're not and your code's pretty self-explanatory, then there's no reason to. However, I'm going to tell you guys how to write comments. It's very simple. If it's single line, it's just slashes, right? And then single line. Pretty easy, right? If you want to write another line, you just add another line, another slash, and say add line, right? And you just write your next line. However, if you are going to do multi-lines, sometimes it's better just to use the multi-line, which is a slash and an asterisk. And then you write however many lines you want inside, and then you close it with an asterisk and a slash, right? Is that the same in Java?
Yeah.
Yeah, that's what I thought. So that's it. There is also something called EOS, which you guys are welcome to look up. EOS is pretty cool. It allows you to do multi-lines and stuff like that as well, but it's a little bit far beyond this course. So, cool. Awesome. Do you guys want a break? Does anybody want a break? Put your hand up if you do. Then we're going to keep powering forward. All right, I'll ask again after we do the arrays part. I mean, we're only about, what would you say, 15% into it. So after 40 minutes, not too bad. Now this should be a recap, right? You guys have worked with arrays. Granted, arrays in JavaScript are very different, right? You guys did PHP. You guys used arrays in PHP, right? Arrays in PHP. Just out of curiosity, how many of you realize that arrays in PHP were basically dictionaries? Nobody? They are, right? Because even though they're zero indexed, underneath the hood, that zero is actually a key. It's a key given to the value. It's not a true array that's actually properly indexed. It is technically a dictionary underneath the hood. That's why in JavaScript, we don't get hashes. We don't get anything like that. We always just work, in PHP, we always just work with arrays. Sometimes they have keys. Sometimes they're implied. In JavaScript, however, that's not the case. In JavaScript, you have arrays that are properly zero indexed, and they work like a normal array. Where it breaks arrays, though, is you can put any value you want in there. It doesn't have to be the same data type. So you can put a string, a boolean, a number, and another array, and an object in there, all within the same array. It doesn't have to be data types. It is best practice to keep your data separate, obviously, to keep your data types. It is better practice to do that, but you don't have to. Another thing about JavaScript arrays versus strict languages like C++, C#, or Java, you don't have to define the size of your array at runtime. It can grow as it needs to. It can shrink as it needs to. They are dynamically sized. You control it as you progress through your application. And the biggest reason for that is that JavaScript is not compiled, right? You don't run it through a compiler and then spit it out. It's interpretive, which means there's an interpreter that runs through the file line by line and interprets it, sends out the command, and then writes it to the browser as it goes. When it hits a function, it executes its function, returns its value back to the browser as it goes. But it's interpretive. It's running on the fly, line by line by line. So you get some cool things like implicit data typing, dynamically sized arrays, event-driven behavior. You get a lot of this stuff because of that idea. So, syntax for an array, though, is fairly similar to other languages. Arrays are denoted by the square brackets, right? Just like they are in many other languages. It's a square bracket. And then inside the square bracket is where you put your values. In JavaScript, you can define an empty array. That's totally fine. So say if I wanted to create an array called letNames equal, which implies I'm going to make a list of names, right? I can initialize it as an empty array and then add my values later if I so choose. The cool thing about JavaScript is I can even do, there's two different ways I can do this. I can either, there's methods I can run against it to add new items or remove items. But I can also just go names, put an index in there, whatever index I want, and then add my value right in line. I can also totally skip 0 and go straight to 3 if I want to. And then what it will do is it will put two empty, undefined values in 0 and 1. So I can move through my array, and I can use my array basically as a placeholder and kind of keep track mathematically where things are located, which makes arrays pretty awesome. As I said, they are zero indexed, like they are in most languages. There's only one language that, and I think it's like Perl or something like that. It's a known language too. It's like either Perl or Python or something like that that isn't zero indexed. It's actually indexed at 1. Which breaks my brain, right? Because I'm so used to zero indexed. However, as much as I would like to say that it's not a case, this catches about 20% of all students who take this class. They get stuck on the fact that they think the arrays start at 1 but they don't. So I like to ask a lot of questions of like, hey, where's this value? At what location is this value? And a lot of people make the mistake and start at 1. And you shouldn't. Just make sure you always start at 0. So we're going to do a little bit of this. If you open up your main.js, you'll see the step 1 for our first part in here for our first practice. And you guys are kind of lucky because there was some bugs in this, but the bugs have been ironed out because Monday's class ironed out the bugs. So you guys hopefully get bug free. Not guaranteeing it. Don't hold me to that, but hopefully it's bug free. All right, so the first one we're going to do is we're going to assign the provided variable a 3-item array. Make all 3 items your favorite foods. So what data type are our foods going to be, obviously? Strings, exactly. So we're going to say equals, and what's the syntax I need here to denote an array? Square brackets, that's right. So go ahead and type whatever you want. I'm going to say pizza. Yeah. I'm going to say Mama Burger because I'm going to get one of those after work. They're on for $3. Like, I mean, that's so cheap, right? Maybe I'll swing by Wendy's and get the Dave's Burger because it's also on $3. And then maybe I won't be in next week because I'll die from a heart attack. And why don't we top that off with some pizza? Yeah. Let's do some pizza. Oh yeah, they're on $7.99 at Pizza Hut right now. See, I know where all the dirty food is. All right, I'm going to save that. And then obviously you have to refresh your browser. And if you did it correctly, you should see it spit out your values in line there. On Monday, it spit out my values. Now it should spit out yours. So you should see whatever 3 foods you chose in that area. Cool. Step 2, access the first item in your favorite foods array. Okay? So the first item, right, like I said, arrays start at what index number? 0. Exactly. So this is very important. This is extremely important. This is not the same as this. These variables are different. I'm saying that because I've already marked Monday's lab, and this was a common mistake, thinking that as long as the letters are the same, that it's totally the same thing. But you have to understand those labels are evaluated at the binary level, and capital A and lowercase a are not the same thing. So make sure you use the correct. Hi guys, how you doing? Make sure you use the correct syntax there. Add your square brackets at the end, and like you said, we're going to access at 0. So I'll refresh over here, and cool. We have my favorite foods. And if you did it correctly, your syntax should spit out on the other side. Not guaranteeing it for next week, but this might be a bit different. We might not be using the IDE. I'm going to try implementing something called CodeMirror, which is what they use in CodePen and JS Fiddle and stuff like that. And if it works out, essentially what will happen is you will have your evaluation on one side, and you'll have a tiny little IDE on the right side. And you'll just type directly in the IDE. So hopefully, not guaranteeing it. Just depends on how the weekend goes. All right, so step 3, access the last item in the array. There are definitely more efficient ways to do this because, like I said, these things are dynamically sized. So you can't guarantee that 2 will be the last item, right? Especially if people have added more items in there. But for simplicity, until we talk about functions next week, we're just going to enter 2. Cool. This is a good segue into talking about your first debugging tool that you guys are going to get to use, right? Debugging, probably one of the more important things when you're doing programming, right? We're not going to get into error handling this week because it's a little too advanced for just starting out, but we should at least be able to see when things go wrong, right? We should be able to at least tell if our code is executing or if our code has a problem. Now, I've kind of done you a favor in the fact that these little snippets that show up here, I have made them interactive. I've made them so that they will show you an error if there is an error, right? So if you were to forget, for example, to add the 2, say you chose the wrong index number and you chose 1. If you refresh, it should tell you you have chosen the incorrect index in the file. Okay? But that is not the normal nature of JavaScript. That is the result of a file that I use called evaluate.js, which is a library that I've created that evaluates your stuff, right? It helps you guys along and helps with your learning process. The better way to do this is by using the console. And just give me 1 second and I'll tell you how to open it. I'm just going to stick it off to the right-hand side here. And zoom in a little bit so you can see what's going on. This is the console, and the console actually outputs information about your script, about what you're currently writing in your main.js file. This thing will tell you if anything has gone wrong, any information about what may be occurring. So for example, if I take this file and I bring it over here, and say I forget this bracket, my library is not going to catch that. And it's not going to stop your script from blowing up. Your script is just going to blow up. If I Command R over here, you can see at the very top it says uncaught syntax error, unexpected token on main.js 6. So what this is saying is, first of all, it says uncaught syntax error. Syntax errors means there's a problem with what you've written. Okay? It's not a logic error. That's not the issue. The issue is your syntax is incorrect. You've done something weird. Okay? Unexpected token semicolon says, hey, this semicolon on this line shouldn't be here yet. You're missing something. You haven't completed your sentence. Okay? You shouldn't be terminating because you haven't completed the statement. And then main.js 6, anybody want to give a go at what that means? Name of the file, yeah? And the line number it's on. Now, that can be misleading. When files are including files that are including files, it can say something is somewhere, and it can be blatantly wrong. You might have to scan down to find out where the root of the issue is. But this one is accurate, because if you look, our syntax issue is on line 6 of our main.js file, and it's because we're missing this bracket. If I put the bracket in, you can see the little red error goes away. Right? These error messages that you see in here currently, I'm giving you these errors. I'm using my application, I'm executing something called a try-catch, and I'm throwing an error. But that's me physically throwing the error to the browser. That is totally different than a syntax error. Okay? And my errors will never be read, and they will always say error on them. Okay? So there is a difference. Last but not least, obviously, you need to know how to open this wonderful thing, so I will show you how to open it. In fact, I've given you a table. This table here will show you which browser you're using. It will tell you if it's for Windows or Mac. Unfortunately, I didn't include Linux, but if you're using Linux, just use the Windows shortcuts because they're the same. And I support Chrome, Firefox, Edge, and Safari. Just keep in mind, if you're using Safari, make sure you read this note, because you need to enable your developer tools in Safari. What I would recommend to make your life a lot more simpler, use Firefox, use Chrome. It'll make your life so much easier. Both have better JavaScript tools in it for debugging. When you're working with JavaScript, they make the most amount of sense. And arguably, Firefox definitely has the better JavaScript tools when you're learning. Okay? They have this thing called Firebug, which is now embedded into the browser, and it definitely makes learning a little easier. But if you like Chrome, like I do, and you want to just use the same browser I am, go ahead. So if you're in Chrome, you're going to hit F12 or Control-Shift-J. If you're on a Mac, you're going to hit Command-Shift-J. Okay? F12 is usually the quickest way there. Firefox, same thing, F12 or Control-Shift-I. Unless you're on a Mac, and then it's Command-Shift-J. If you're in Edge, it's Control-Shift-I, and then you need to select Console from the tabs. And if you're in Safari, you need to enable your developer tools if they aren't already enabled. Then you're going to go through the menu and go to Develop, Show Web Inspector, and then click on the console tab. All the browsers will open up a panel. Whether or not they're dockable is hard to say. Usually they open up like this, so they're at the side of the screen. However, you have the ability to place your panel. If you're using Chrome, it's very simple. I'm not sure how you do it in the other browsers, but in Chrome, you click on these three little dots, and these dock sides are how you move it around. So you can dock it to the right, to the bottom, to the left, or you can undock it into a separated window, and that allows you to just treat it as a regular window at that point. The other panels that are at the top, the other tabs, these are various things for inspecting your CSS styles, inspecting the HTML hierarchy on your page, which will come in handy when we start talking about the DOM. This panel will become very handy. There's application, which will actually show you what's currently stored in local storage, talk about your web SQL, stuff like that. You can also clear your cookies in here. Incidentally, if you've been to a site and you want to get rid of the cookies because they're, some screwed up nature is happening and you want to just get rid of them, you can actually go into application, go into cookies, and just click clear all, and they will disappear. They'll be gone. A lot easier than just destroying all of the cookies across your whole browser history, which means now your banking information needs to be retyped and everything needs to be retyped. You can do it per site. There's a network tab. The network tab actually shows you your files as they're being served by the server. So your server is actually your local machine. That's what's currently serving for you. This shows you basically how long it's taking for each file to load. You can actually see errors. If they're red, you can click on them and see what the error message is. Very handy when you're debugging server-side content as well. There's sources, there's performance, memory, security, audits, and ad block. I'm not going to get into all that. Suffice it to say that there's tons of different tabs. The only ones I really care about are the console, the elements, the network, and the application. And we won't even be touching the application tab until we get to local storage and cookies. And then we'll touch it then. All right, any questions about the console? Cool, because we're going to do some stuff in it. All right, if you scroll down a little bit, you will see this thing that says, let's work in the console a little. And the first one says, open your console and copy and paste the message into the provided variable. Now, it's none of the error messages. You're not looking for an error message. You're looking for something that doesn't have the word error in front of it. All right? You're going to copy it verbatim. Right? So that means literally. Because if you don't copy it verbatim, then the script on the left-hand side will tell you it's wrong. All right? Does anybody want to give a guess at what likely the message is? No? If you look through the list, there's only one that doesn't start with error. Yeah.
Falcon flies south for the one.
Yes, it does. All right. So you can copy that. I'm going to copy that. I'm just going to go in here. I'm going to highlight it. Whoop. There we go. I'm going to copy it by hitting Command-C, or you can hit Control-C, or if you're really old school, you can right-click and choose Copy. But by this point, you should be Control-C'ing all the time, right? All right, so I'm going to Command-C, because I'm on a Mac. I'm going to jump over to my Sublime Text, and down here is Step 4, and it's an assignment, right? So I need my equals operator. And can I just do this? No. Why is that bad? That's right. Look at all those wonderful words in there that the interpreter is going to freak out about. It's going to think the falcon flies south are all variables. It's going to think for is a loop that we're starting, that we're just not doing anything with it. So we need to wrap these in a what? Some quotes. Single or double, doesn't really matter. Or backticks if you're so inclined. Backticks are fantastic. They're the thing that's underneath your escape key that you get when you don't press Shift tilde. All right, we'll explore backticks a little bit further next week because they allow us to do something called string interpolation. And they're kind of handy to have. So if you click refresh and you did it correctly, you should see the falcon flies south for the winter. If you see that this is not the correct value, then you likely didn't copy and paste this correctly. It needs to be pasted verbatim, meaning the period needs to be there, everything needs to be there. All right, so using the console.log syntax, cool, let's talk about console.log a little bit. In order to talk about console.log, I need to give you some insight into JavaScript. And I kind of hate this because there's really no place, there's no place in time that seems to be perfect to talk about this, because it's something that you come across in JavaScript really quickly. And that's that most things in JavaScript are objects. Like 90% of the things in JavaScript are objects. The only things that are not are the primitive data types. They're the only things that are not. So any primitive literal, so like a literal string, a number, a Boolean, any literal is not an object, unless it's a literal object. But whatever. Anyways, that was a dumb joke. The point is, though, is that because of that, you have to understand that as objects do, they have some features to them, right? So when you make a class, right, and in JavaScript, you give that class two things at all times. You give it descriptors, right, or state, which are usually stored in what? They're usually stored in data members, right? Like variables, properties, attributes, fields, whatever you want to call them. One of those bloody words. I tend to call them properties, right? They're properties. And then the other thing is, what do you define functionality in? Methods, right? Usually in your methods. So, like that, you can think of that the same way as in JavaScript. However, the thing that kind of throws you off is you're not instantiating these objects. They just exist. They're already there, right? You're not actually creating new versions of them. They're just there. They're there for your use right out of the box. They're a part of the JavaScript API. They're already instantiated. They're already functioning. You can use them right from the get-go. And in fact, you already have been using them. You just haven't realized. You've created several of them, and you didn't even know you were doing it, right? That's because, like I said, about 90%, no, even more than that, probably about 98% of the things you'll interact with in JavaScript are objects. So that gets down to this. Using the console.log. Right? So let's break this down. Which part of that is the object? Anybody want to guess? All right. Console. And the cool thing about this is your Java experience should help you with this. Which part of this is the object? Right. That's our OBJ. What is this thing? Cool. Yeah, we'll call it that. We'll say it's the method, right? We know that we're calling something on our object because of this wonderful operator, the dot. The dot is our segue into either accessing a property of our object or accessing a method. This should not be new. You guys are working in Java constantly. It's no different. The only difference is you didn't have to create a new one of these. It already existed. It existed the second you turned on your browser and opened up a website. Actually, it existed the second you turned on your browser. It was there immediately. All right? So we can actually utilize that. Does anybody want to take a guess at what it does? No? Yes, you're 100% correct. It prints crap out to the console. It sticks it in the console so that we can actually see it. If we're in the console, writing console.log is a bit redundant. It's a bit redundant because we're already in the console. Console.log runs natively when you're in there. If you type in a raw value inside the console, it immediately invokes console.log and spits out whatever your value is. So writing console.log hello world, like I just said, is redundant. We don't actually need to do that. All we really need to do is just write out hello world. And that's totally cool. Console log is implied. But I mean, you can for verboseness if you really want to. So, step 5, using the console log syntax, output the value of my secret var. Like I said, console log is already just redundant. What is the value of my secret var? Go ahead, type it in your console.
256.
Yep, 256, that's what it is, all right. My secret. Notice something too, as I type, it wants to help me. It gives me a list of things that are available there already, so I can actually easily see quickly what it is that I'm looking for. So cool, it's 256. So let's jump over to our IDE real fast. Step 5, using the console log syntax, output the value of my secret var and copy and paste the value in the following variable. So we know equals 256. Refresh the left-hand screen, and it should change to 256. Let's do the next one. Using the console log, output the array value of my secret R. Okay. We'll jump over to the console. Now I'm clearing this just to make my life a little simpler. You can clear it with this clear console button at the top, or you can hit Control L if you're on Windows, or Command K if you're in Mac. I don't know about all consoles, I just know about the Chrome one. So it might not work, it might do freaky crazy stuff in Firefox, I have no idea. Alright, so we're going to type in my secret R. Cool. That shows an array, and it says record how many elements there are in the following variable. How many elements are there?
4, 5.
Right, there's 5. It's a bit of a trick question, right? There are 5. There are definitely 5 physical things in there. It's not what index we're starting at. It is how many items are in it, right? And what's cool is it actually tells you. That's what those brackets and the number inside of it means. It means how many elements are currently inside this array. And what's even more cool about your console is it's interactive. You can actually click the little gray arrow beside it, and it will show you the index that each one of these is starting on in order. In addition, it will give you information like length, right? That is because, anybody want to guess what my secret R is? What's this thing?
Oh, it's not going to do it.
It's an object. My secret R, even though it is an array, it is currently wrapped in an object, which means it has properties, it has functions, all available to it. Right? Right? That's how JavaScript tends to confuse people. Right? But that's exactly what's happening. And length, what would that make length? If my secret array is an object, what is length? It's a property, right? It's a property. And so is 0. And so is 1, 2, 3, 4. They're all properties technically. They're indexes, right? We're calling them indexes, but they are properties. Okay? So that's important to understand because it leads on to later when we start using methods on this thing. Just willy-nilly. Right off the bat, without instantiating, without wrapping it in any objects, without doing anything weird with it, we're actually going to use methods directly on it. Okay? Cool, so we need to state how many elements there are, and there's a couple ways we can do that. We can do equals 5 and type it in. Actually, we have to do it that way. We have to do it this way. We're just going to type it in hard code. I mean, we could use my secret r.length, but the problem is the script that I use to evaluate that actually define that variable comes after your stuff. And because it comes after your stuff, you can't use a variable unless it's defined, right? So it's after the definition. What's that?
I actually put my flag inside the bracket and it works.
So you wrapped it in parentheses?
Yeah.
So that's totally cool. That's fine. That's not wrong. All it does, though, is it basically says, I'm going to evaluate this. It's 5. And then it stores it. So you're just going one extra step for no reason. That's all. I'm going to take mine, just like you could also, if you wanted to, if you were so inclined, you could wrap it in curly braces too. It doesn't matter. But it's definitely more efficient to just use the literal. Yeah. Cool. You guys may not need a break because you're hardcore, but I need a break. I need a drink. So why don't we pause and then we'll come back to nested arrays.
You can also be able to
All right, so we're going to talk about nested arrays. Nested arrays are definitely one of the more confusing things for people, and you know what, that's totally fine because when you program a lot, you try to keep your nested arrays down to a bare minimum, right? Like this size of an array is not common. However, it is something to be aware of. For example, our G-Shift system, we build these great big CSVs. CSVs stand for comma separated values. And the way we build them is we pull a lot of data and we basically parse through our data and we separate it into the columns that we need in order to illustrate, you know, the way that the way that data looks. And it's not uncommon for us to have, you know, about 2 to 3 nests going on in there in order to illustrate that in our CSV or inside Excel, or what else do we export to? PDF. We export to a few different things. So understanding how these structures work, understanding how to access data and iterate through these structures is important, especially now with the industries all going towards big data. You're working with data analysis. Knowing how to build this, knowing how to work with the data that's inside of it is crucial for you being successful, right? So anyways, nested arrays, they're quite often used to store tabular data. That's like most of the time that you're using them. Most of the time you're using them is for tabular data. That's usually what it's for. If you take C++, you guys are off next semester, so if you take C++ in September as your optional, we use arrays quite a bit. If you have me, we use arrays quite a bit because you use arrays to store, you know, like student data and then piece it all together and then store those in files. Arrays are really good for file storage, but that's like we're talking about a fairly mid-level language. You know, it's not as sophisticated as JavaScript or Java. That being said, you know, all this stuff compiles down to it anyways. But all right, so this array example that I've given you here is students. And I've kind of taken the C++ methodology behind it where each one of the arrays corresponds together, and I'm basically using the indexes to kind of map everything up, right? So, for example, the ID 56790 correlates to Bob Alto. So Bob is his first name, Alto is his second name. The classes that he has taken, does anybody want to give a guess at what classes Bob Alto is taking? Yeah, exactly. French, science, and geography. And his current grades for those courses, what's his grade in science? 83. Yeah, exactly. And the way we're doing that is we're just using the indexes to move through, right? And this can become confusing for a lot of people because indexes are zero-based, right? So this is 0. That starts at 0. So if I go to students, 0, I'm accessing the ID array. If I go to students 1, I'm accessing the first name array. If I want to access Bob, for example, I would go to students, right? So access my array. I would start at 1, right, for the first names. And then because the value of 1 is an array, right, it starts at 0 again. So if I want to access an element inside of it, I just provide another square of brackets for that next array. And it's also 0 indexed. So I go 0, 1. So to access Bob, it's 1, 1. That's the way that works. If I want to access, say, Bob's second course that he's taking, the second course that Bob is taking, again, it's students, right? And I'm going to first start with the outside array, so I'm going to go 0, 1, 2, 3, right? So it's going to be 3. That gets me that array value. And then I want to know his second course. Well, first of all, I need to access the correct array for him, right? So it's 0, 1, 2, 3. Bob is the second one in, so it's going to go 0, 1. And then I want to know his second course, so it's just 1. So students 311 will return back science, right? And we can test that. Your console allows you to type JavaScript directly into it, right? So you can actually parse JavaScript right within your console. For example, you can do let x, let's choose a letter I haven't used, let u equal 25. Now u is defined inside your console, right? So you can type JavaScript directly in your console, which can be very handy when you're trying to test your code. But you can also take a look at variables you've already defined. So students is already defined. So I can actually start typing out students. And I can hit enter, and I will see all of my arrays there, right? And there's that wonderful arrow that makes things very handy for me to actually look through my stuff. And I can click the arrow, and you can see all of these have arrows. So I can click this arrow, and then I can click this arrow, right? And I can drill down and see all my values. So I can actually test my stuff. I can go students. I know Bob is in, so I said it was 3, right? So I'm going to start at 3. That returns back this array, right? If I want to make sure that's the correct array, I can hit enter, and I can see, yep, it's the grade arrays. If I want to show the code I just typed, I can press up, and it will actually spit out that code, and now I can edit it. So I'm going to do another square bracket, right? And I said 1. Here we go. Sure enough, there's Bob's classes, French, science, and geography. And if I press up again and add in another 1, there's science. So 3, 1, 1. And I get Bob's course that he's taking, his second course. All right, so we can actually use our IDE, and we can go ahead and solve these problems. So let's open up our IDE, right? And the first one is step 7, which is access and store Dave's science grade. So I'm going to scroll down so you can see this wonderful thing. And go ahead and try to access Dave's science grade. Give you about a minute. All right, see if you can figure it out. Use the console if you need to. Make your life a little simpler. Incidentally, when you guys are doing the quizzes, you can still open another window. You can actually open the console in Blackboard, right? It's going to be full of crap because they have so many errors. But you can clear it out and start typing stuff directly in there and use that as a way to help you with your quiz, right? Take advantage of all the tools you have. All right, cool. How do I access Bob's grade? All right, so we say 4, 0, 1. Cool. Let's see if we're correct. We'll refresh. Cool. Dave's science grade is a 53. Gonna fail, Dave. You don't know science. I completed the second one for you, and that was completely by accident. But it's completed for you. That's in order to access Bob's last name. It's 2 to access the last names, 1 to access Bob's index, right? What about storing Bob's geography grade? I'll give you a... Oh, somebody's already solved this. Cool, let's do that. So it's equal to students, and what's the first one? 4, 1, 2. All right, let's try that. Yep, that works out. 82. Bob's decent at geography. So, just a note. These show up on midterms, and they show up on finals, and they always catch people, right? So practice this, because I do like to put these on tests, because they're kind of fun for me. I don't know why. I like things like Sudoku, that's probably why. It's kind of like a big Sudoku puzzle. All right. We're not going to spend tons of time with nested arrays. We will be iterating through nested arrays at some point, but not today. we're going to move on because there's more basic stuff about arrays that we need to cover. You may see this emoji, you may not. Depends on whether or not you have the character coding for it. But I've written here, everything's an object with the classic meh face, right? You know, the meh face basically means no, I don't think that's true. And that's true. But when you're scouring the internet, or if you watch some of the other instructors from Georgia talk about JavaScript, this seems to be a classic myth that people like to state, that everything's an object. However, I can tell you that if you write that on Stack Overflow, you'll get flamed. They will just roast you alive. Because it's not true. Primitives, such as string literals, or the number 5, or true, they are not objects. Okay? They're not objects until you try to do something object-like with them. They start off as primitive data types. They start off as primitive values. Okay? So it isn't correct. However, it is correct to say that most things in JavaScript are objects. Most things you will work with are an object. So, like I said before, this is kind of a bizarre learning path because you don't usually learn about variables and conditionals and then jump straight to objects. That's not usually a classic pathway. Usually, you start off slow, you learn how to write some loops, you learn how to do some, common if logic, and then somebody slaps you with a class, and then you learn about classes, and then you learn how to instantiate that. But no, JavaScript, because everything you're working with stands a very possible chance of being an object, it's a good idea to understand what you're interacting with. But it shouldn't be new for you anyways. You've worked with objects, right? You work in classes when you do Java. I'm sure you've instantiated those classes, and I'm sure you've worked with their properties and methods by this point. So it's not going to be too much newness for you, right? Don't get hung up on why it's there. Don't get hung up too much on the fact that you didn't instantiate it. Just ignore that for now. We'll deal with that later on. We'll talk about why that is later on. For now, just understand that it's an object. And it works just like how you guys are used to using objects. You can press dot, and now all of a sudden you've got properties and methods available to you. Okay? That's basically, on the simplest level, that's basically what's happening. So, I'm going to use the terminology properties to describe solid values on an object. Okay, so state or descriptive properties. I'm going to use the word properties. And then I'm also going to use the word method to describe functions. And you may be like, well, that's a really strange thing to announce because of course you're going to use properties and methods to describe these things. Like, why wouldn't you, right? A function is a method, a property is, just a regular value. But there's a reason why I'm stating that, and that's because JavaScript objects don't have methods. They don't. They only have properties. That's all JavaScript has, is properties. However, a property can be assigned a 5, which is a number, be assigned true, which is a Boolean, can be assigned an array, can be assigned an object. It can also be assigned a function definition. A function definition is the syntax you use to create your function. Okay? But it is not a method because you don't have to execute it to tell everybody what your function is. You don't have to execute it to spit it out somewhere else. You don't have to execute it to pass it. You can pass it around your application without ever executing it at all. What defines the actual execution is this cool operator, the parentheses. They actually execute the function. But that's more advanced, and I feel like it simplifies it to just state values are properties. Methods are anytime we assign a function. Okay? We'll just call those methods. Cool. So, let's talk about size matters, right? Everybody tells you it doesn't, but it's a lot. Array length. Array length is that wonderful property that's sitting on the array. And that is a property, right? Because it tells you, it returns back a number, right? It's not a function. You're not adding parentheses to the end of it. You're not executing anything. It is just a solid value that you get back from the array. So when you call array, right, dot length, you get whatever's inside of it, how many number of the elements that are inside of it. Array lengths are fantastic because it allows us to be able to tell information about the array that we don't control the size of, right? Because they're dynamically sized. They grow, they shrink, they do whatever, and you don't necessarily know how many elements are in it at the time that you're trying to access it, which is very important, right? Because if you want to iterate over it, you kind of need to know how many elements are inside of it. You don't want to just be like, cool, there might be 100, so I'll just iterate 100 times, you know, whatever. No, let's be efficient, right? We can find out how many elements are in there. If there's 67 elements, there's no reason to iterate 100 times, right? If there's 170 elements, we definitely don't want to iterate 100 times because we're losing out on 70 elements, right? So it's important to know, and we can do that by calling dot. Now the cool, interesting thing about it, this is where I'm going to type JavaScript directly in the console. The cool thing about it is you can call dot length on any array. It doesn't even have to be instantiated. It doesn't even have to be assigned. You can literally just write the square brackets operator and call dot length. And of course, there's nothing in it, so it's 0, right? There's no elements in it, it is 0. Again, we don't have to assign it. Let's throw some stuff in it. Let's throw 1, true, and Bob in it. Now our array.length is 3. There are 3 elements inside our array. Now it's important to understand that length is a shallow count, okay? And what that basically means is it will only count the first level of elements. So we've been playing with students a bit, right? And students, we know, is a multi-nested array. However, if I do students, actually, let's just spit out students so we can see. You know, there's 5 current values, array 3, array 3, array 3, array 3, array 3, right? There's like a ton of elements inside this array. However, if I do students dot length, I get 5, and that's because it's a shallow count. It's only going to count the top level elements inside of it. If I want to know how many elements are in the next array, then, well, it's up to me to move into that array and then call dot length on it, right? There's no way to recursively go through and find out how many elements altogether are there. There's no way natively to. You can write your own function that does it, but there's no way natively to do that. Okay? So that brings us also to this wonderful thing. We keep talking about these objects, and I've said before, the console is a really handy tool because it gives us a lot of valuable information. It has this wonderful interactive thing where we can actually click the arrow here, right? And then we can click another arrow, and then we can click another arrow, and we can like interact and see what's available to us within this array. That's not where it all ends, though. What's kind of neat, I'm not sure if you caught this, but when I did the square brackets and I pressed dot, I get a list of properties and methods that are available to me based on my array structure, right? So I've got dot length, that's the one we talked about, but I also have concat, I have constructor, I have, you know, filter, map, flat map, for eaches, joins, keys. I have tons of things available to me in order to work with my array, right? And I recommend when you're home and you're like practicing your JavaScript, as I know you're doing, when you're at home practicing your JavaScript, give some of these a go. Try to figure them out. If you don't know what it does, where can you find out? What's that? Console, yeah, well, console's not unfortunately going to tell you what it does. What's our textbook? Wow. MDN. Use MDN, Mozilla Developer Network, right? Mozilla Developer Network, all I have to do is go over to my little tab here, open it up, and I say dot length. And if I want to get more specific, I'll write JavaScript. Bam! Usually the top result is W3 Schools, which is fine, you can use it. But the next one here, array.length from MDN. Let's click on it. Gives you an example of how to use it. You can even run it, give you some output, right? Shows you some more advanced examples on how it works. Gives you an explanation of what it does. You know? Shows you some more examples, and it also tells you what browsers support it, right? Which .lang supported everywhere since ECMAScript 1, right? So it's pretty widely supported. MDN, should bookmark it. Definitely is very, very handy. All right, so we're going to play around with .length real fast. We're going to come down here and saying, using .length, how many elements does the student's array have? Well, we already know the answer is 5, but we don't want to hard code it, right? Even though that won't break the evaluator. The evaluator's not smart enough to know that you actually use .length. But I mean, let's practice. So we'll do students.length and save it. If you refresh, it should say the num of students is equal to 5. Right? Let's do the next one. Using .length, how many elements does the student's first name array have? Well, we can't just do students.length here. We need to pass it what index number?
0.
Well, 0 is the student's IDs, isn't it? We want the first names array, 1. And then we can call .length. And then step 12, using .length, how many elements does the student's course list have? So we're going to say equals students. And what array is the course list on? 3? Yeah, is it 3? I'm taking your word for it. So .length. And if we refresh, cool, it works. I mean, at the end of the day, it just had to evaluate the 3, so and we're good. So .length we're going to say as a property, right? Because we don't use parentheses at the end of it, so it's not a function, right? So it's not a method. We're not going to call it a method. We're going to call it a property. But I think it's important for us to talk about some of the array methods that we have available to us. Because obviously, what's the point in having a dynamically sizable array if you can't add and remove elements from it, right? We want to be able to do that. So there's a few methods that we have for adding elements to an array and removing elements for an array. Like the property .length, arrays also provide methods for adding and removing elements. We have 2 common ways for adding elements to our array. 2 common methods, I should say. The first method is push, right? Push, I found out on Monday, you don't have push in Java, which I didn't realize. How do you add elements to a list in Java? Is it .add? Oh, okay. Yeah, so in C and C++, it's .push, right? In Ruby, it's .push. In PHP, it's .push. Well, actually, it's not .push. It's just push. Other languages use push, but so I thought it was kind of weird that it doesn't use .push. But so in JavaScript, it's .push. It starts out with whatever your array is. I'm just going to use this syntax. And then you can access the method dot and it's push. Now, because it's a function and we're executing it, we're going to put a parenthesis. Push takes unlimited arguments, technically. It takes a list, is what it takes. But the list isn't an array. You don't format it as an array. It takes just a list of separated values, comma-separated values, however many you want until you run out of RAM, right? You can put as many as you want in there. You can put 1 in there, right? You can put, a few in there. Right? But notice the commonality here is that they're all separated by commas. Okay? That's the important thing. They're separated by commas. However, this is not legal syntax. Okay? JavaScript does not support what's known as trailing commas. So don't do it because it will break. Make sure once you reach the end of the list, you stop with the commas. Okay? So push accepts a list of items that are separated by commas. And we can play with that a bit if we scroll down here. Are you serious? Why did I do it this way? This is so weird. Usually I put examples directly underneath each one, but it looks like I lumped them all together at the very end. So we'll do step 13, and then we'll move on to unshift and talk about it, and then we'll move to the next one. All right, so step 13, using push, add 3 numbers to the initialized array. So this is our array. So to access our array, we type in init r, right? Then we type in dot push, and we give it the brackets, right? Which means we're executing a function. And we just enter whatever our items are. So it says add 4, 5, and 6. I'm going to do 4, 5, 6. And those are now in my array.
It's not working for me.
Yeah, it's not going to. Yeah, it's not going to work until we complete the rest of the steps. Yeah, if you click refresh, it's not going to say a darn thing. Yeah. All right, in order to complete the next step, we need to learn about unshift. So push does something interesting, and we can actually see that. We can actually load up this wonderful thing over here. Right, I'm going to clear it out. And I'm going to type in init r, because my variable is available to me. And I'm just going to spit it out. And you can see, where did 4, 5, and 6 get put inside our array? At the beginning or at the end?
At the end.
Exactly. So push adds elements to the end in the order that you've added them. Sometimes we want to add elements to the beginning of our array, right? Say we're creating like a job scheduler and we want to add jobs based on priority. This is a common practice, actually. You want to add a job to the beginning of the array, right? Because you want that job to get popped off and executed next, because that's the priority, right? So in order to do that, we need a method to be able to add them to the actual beginning of the array. So the way we do that is we use something called unshift. Unshift will actually take the element, as the example shows right here. It takes the element and it pops it to the beginning. And just like push, you can give it a list of items. So it will take one element, if you want to give it one element, or you can give it a few elements, or you can give it as much RAM as you possibly have in elements, right? And it will tack all those onto the beginning of the array. So why don't we do that? Step 14, using unshift, add the following 2 numbers to the array. So we're going to do init r dot unshift is the name of the method. And you would think, this is weird, because some people think this, and I kind of thought this at first too. When you add unshift, right, and you're like dot unshift, okay, I want my list to go 7, 8. So I'm going to put it in reverse order. I'm going to go 8, 7. Because this will get added to the beginning of the array, and then this will get added to the beginning of the array. But no, that's not how it works. It goes 7, 8. And then 7 and 8 wind up 7 and 8. Okay? So that's important to understand. So we're going to add 7, 8 to the beginning of our array. Okay? Now if you open up your console, we'll have to refresh, and we type in it R. You can see 7, 8 has been added to the beginning of the array. Then 1, 2, 3, which was what we started with, and 4, 5, 6 is at the end of the array. Cool, cool, cool. So adding elements is cool, but removing elements is also sometimes necessary. Like I said, if we go back to the example of having like a job server, right? Has anybody actually worked with Redis before? No? You will. You likely will. Redis, you can think of it like an array, right? It's a big list of items, and you just put them on, and then the job server takes them off and executes them. So same idea, right? We need to be able to remove our items from our array, and we can remove from either end. We can remove from the beginning or the end of the array. So why don't we first remove from the end of the array? We're going to use something called .pop. And the removal ones don't take any arguments whatsoever. They're empty. A lot of people like to add arguments to them, and it's pretty cool because it doesn't actually care. It doesn't get mad about it, it just ignores them. It doesn't execute them, it doesn't do anything with them. It just completely ignores them. But you can only remove one item at a time with these next two methods. .pop will only remove one item at a time. So if you want to remove 7 items all from the end, you have to call .pop 7 times, right? So, and the way that looks is you put your array in, and you call .pop, and it's a function, so make sure you add the parentheses to execute it. And that will remove the element from the end of the array. So which element's going bye-bye? That's right, 6. Say goodbye, 6. You're out of here. All right. And we can just double check that. If we refresh, type in init r, you can see 6 is now gone because we popped it off. Obviously, you can remove from the end of the array. We definitely want to be able to remove from the beginning of the array as well. And in order to remove from the beginning of the array, we have something called shift, right? So unshift adds to the beginning. Shift removes from the beginning, okay? So to do that, it's just init r dot shift. And again, it takes no arguments. And again, if you want to remove multiple elements from the beginning of the array using shift, you have to call it multiple times. So once again, we can jump in here real fast and see which element was removed, and 7 is gone now. So we have 8, 1, 2, 3, 4, 5. The last one we have is very cool, and it's called Splice. And it's kind of a confusing one for a lot of people, because Splice takes up to 3 arguments. You don't necessarily need to give it 3 arguments, but it does take up to 3 arguments in total. It starts with our array. Then the dot syntax obviously takes to fire it off. So splice and the bracket. The first element is the starting index. So where in our array currently we want to start at. And this, remember, just like length, this is shallow, right? So it's only going for the root that you're currently within. If you have a nested array, you're not going to be able to dig into it inside the slice function, okay? If you want to dig into it, you're going to have to actually reference that index and then call slice, or splice, sorry. So the first is the number you want to start with. So we'll say we start 1. So we're starting 1 element into our array. That's where we're putting our cursor, essentially, okay? So this is our start. The next argument is how many elements you want to delete. And this is destructive, okay? When you call delete on init r, it doesn't return a modified array. It literally destroys the current array. So whatever you do to it at that time, you are doing destructively, okay? So if I want to delete 1, I use 1, right? And that will delete 1 element. If I want to do 2, then obviously I call 2, right? So if I don't want to delete an element at all, then I just call 0. And that won't delete any elements at all. So you might be like, well, what's the point then? My cursor's at 1. I'm not deleting any elements. That gets into the last argument. The last argument is a list of items that you want to add to the array. I'm starting at index 1. I'm not removing any elements whatsoever. And I want to add some elements in. So I'm going to add 1, 2, and 3. So what's going to happen is I'm going to jump 1 index over, and then I'm going to add 1, 2, and 3 after index 1 to my array. Okay? Why don't we use this wonderful thing? Using Splice, add the number 256 between the values of 2 and 3. All right, so the first thing we should probably do is check to see where 2 and 3 are actually located within our array, because we have modified it so much at this point, it would definitely make sense to do that. So, hold on. Cool. We'll click this. So 2 and 3. Okay, so we 0, right? 1, 2, and we want to start at, we want to put it in between here. So it should start at 2, but I don't think that's correct. So we can actually test. So let's do init r dot splice right directly inside our console here. If I start at 2, right, and I say I want to put in, I don't want to delete any, and I want to add 256, and I hit enter, I have to type init r again in order to see what has happened. So what you'll notice is I started at index 2, however, where does it insert the items? It inserts them before the index. So in order for me to get my items to go after the index, then I need to modify it a little bit. So I'm going to just refresh. .splice. Change that to 3. And let's see if that's in the correct location. And sure enough, it is. Right? So it starts at the 3rd index now, and it drops it in at the 3rd index, which makes sense. 0, 1, 2. It now becomes index 3, 3, 4, 5. All right, so let's transfer that code over to this wonderful thing. Init r dot splice. We're starting at index 3. We're not removing any items whatsoever. And we're going to add in 256 between those numbers. And after you've done that, if you refresh, all of this should fill in. Any questions about arrays whatsoever? Questions about pop, push, shift, unshift, or splice? No? Length? Nope. Objects? Any questions about objects? Okay, cool. Anybody completely lost? Good sign, either you're great liars or you are telling me the truth and you're not lost, which is great. All right, let's keep pushing on then. We're going to talk about loops, iteratives, repetition structures, whatever the heck you want to call them, right? I call them loops. Maybe it's slang for them. I don't know. It seems like a thing. Loops are a huge part to efficient programming. There isn't a reason to repeat a process over and over again by copying and pasting blocks. In fact, there's an adage that if you reuse a block of logic more than once, literally more than once, then that needs to become a function. And it needs to be repeated with a loop if it makes sense, right? You should never be duplicating logic over and over again. We just mentioned that pop and unshift and push and shift, they don't take any arguments whatsoever, right? And pop and unshift, they can't remove pop and shift can't remove multiple items. So if I need to remove 7 items at the beginning of my loop, then I need to use .pop 7 times. Well, following the rules, no I don't. I should definitely use a loop that iterates 7 times and pops it off 7 times. Better than that was use splice, right? But at the end of the day, you're not going to write the same code line 7 times in a row. That's just bad programming. So we use different loop structures. Interestingly enough, he left, but Rick, who was here earlier, he said to me, he's like, when's the last time, he was sitting outside with me just before class, and he said, when's the last time you used the do-while loop? And I was like, you know what, dude, this is the last time I used it was for this silly assignment thing that we did, this note. Other than that, in my job, I haven't used a do-while loop in years. Or even a while loop. I don't use them. There's just no reason to. Because most times I know how many elements they're going to be, right? Because either I'm using .length, or I'm using some way like count or size or something to count the number of elements that I'm iterating through. Or I'm using a for each type loop, which iterates over array elements. While is very uncommon. In fact, the last time I used a while loop was university for my game dev program, because you use while loops when you build out games. Because it's an infinite loop, the game loop. It's a very classic loop, right? And that's actually a while loop. It's literally while true, right? Which is an infinite loop, while true. And that's because, for example, Nathan Drake, right? When you tell Nathan to move forward, that's going through multiple iterations, depending on how fast your refresh rate can possibly support. So maybe it's 120 frames per second, right? That's 120 actual game calculations per second that it goes through. It iterates 120 times. And during that 120 times, it's not just telling Nathan to take a step forward. It's telling the vertices in Nathan's leg to deform and move X number of positions within 3D coordinate space. It's telling the muscles further down in his leg to deform and move in response to the knee joint changing its direction, right? It's telling this animation to execute. It's telling this game logic to adjust the score by X amount. It's telling his health to execute X amount. Every game loop, there is a lot of information that is happening. There is literally billions of calculations. I'm not being figurative either. I mean literally billions of calculations that are occurring. And you may be like, well, how is that possible? Like my processor can only support so many billion calculations per second. And that is true, but your GPU is like the best mathematician in the absolute world. That's the wonderful thing about GPUs, right? CPUs are great for like intensive processes, but GPUs, when it comes to math, you've got 260 plus cores on your GPU. Each one of those cores is capable of handling a few billion processes by itself. Multiply that by 256. You're talking about teraflops of data just constantly being processed at all times in order to move Nathan from point A to point B to get hit by a bullet at dawn. Right? That's the whole idea. So while loops, that's when I use while loops. Other than that, I very rarely use a while loop. But we're going to write one today. We're going to create, even though we're writing a while loop, this is definitely a job for a for loop by far, but we're going to write it in the while loop. We're going to create a sentinel. The purpose of a sentinel is to avoid things like infinite loops, right? The sentinel basically gives a way to exit our loop. It's a flag that is set outside of the while loop that we can check in order to exit the loop at a certain point based on a condition. So we're going to set the loop, we're going to set the sentinel to 0. Now I've already had one student hand in their lab for Monday and give me an infinite loop and crash my browser. So try to avoid the infinite loop, please. While sentinel, okay, we need to actually go down here. While sentinel, and it says it wants us to increment 8 times. So the first piece of the sentinel is the condition we're going to check. You can think of this just like checking an if condition. We want to basically see while sentinel is less than 8. Okay? Sentinel starting at 0. So the first iteration that we go through, sentinel is 0. Then we're going to run a little bit of a script that increments sentinel. Okay? Next time we run through, sentinel will be set to 1. Next time it will be set to 2, then 3. But each time we're checking to see whether or not it is less than 8. If we don't increment sentinel, what will occur? Exactly. We'll be in an infinite loop. It will go forever, and you'll crash Sean's machine. So let's avoid that. Let's make sure we do this. Though now that I mentioned it, I'm sure somebody's going to just do it on purpose. All right. So while sentinel is less than 8, well, sentinel. There's a few ways we can write this. We can write sentinel equals sentinel plus 1. That's convoluted, right? That's lengthy. There's no reason to do that. Let's shorten that one up a bit. Let's take this plus sign. Plus equals 1. That's a little shorter. That's even better. I like that one. Let's do that. Sentinel plus plus. Nice little incrementer. By the way, did you know that plus plus sentinel is different than sentinel plus plus?
Mm-hmm.
Yeah. Plus plus sentinel? Exactly. Does it before sentinel plus plus, evaluates sentinel, then adds 1 to it afterwards. That can definitely catch you if you're not aware of that. Doesn't happen very often because usually you're not using it in line, but if you're using it in line, then it can definitely catch you. All right, cool. So if that executed correctly, we should be able to Command R that. Boom, it's out on the screen. If you crashed your computer, shame on you. All right. Shouldn't crash your computer. It might crash your browser, though. If that happens, open up Task Manager and kill the PID. Don't know what I'm talking about? Kill the process. All right, write a do-while loop that increments the Sentinel 2 more times. Okay? We're not resetting Sentinel. We're going to use the same Sentinel value. What's the value of Sentinel currently? 8. Exactly. It's currently 8. So to increment it 2 more times, we're going to call do. Do takes a block. Right? Same code inside, though. Sentinel plus plus. Same exact code. However, after the block, we're going to actually write a condition. The way do works is it evaluates after it's executed one time. While will only execute the block if the condition is true, which means it's possible it will never execute. But do will always execute at least once. There's no way around that. It will always execute at least once. Okay? So we write a while in here. Sentinel. And what is my condition that I'm checking against? That's right, less than 10. And if I refresh, you should see your code underneath. Ah. 10 after 9. That is a long day. I've been up since 6:30, so it's a long day. All right, let's talk about for loops. These are the more common ones. These are the ones that I tend to use the most. For loops are set when you know the actual amount of times you want to iterate. That's generally when you use a for loop, right? If you know precisely how many times you're going to iterate, or you can calculate how many times you're going to iterate, then it makes sense to use a for loop. They're efficient, they're fast, they only iterate the number of times you tell them to. I think benchmarked compared to a while loop, they are faster. They're just a good overall. They also read nicely. I feel like they read a little bit more sensibly. There's a few different types of for loops that we have available to us, but both of them work along the same principle. They iterate a set number of times. Many of them take 3 values, right? The common for loop takes 3 values. It takes first our command, right? The first argument it takes is the initializer, right? So we create a variable and we give it a value. All right, that's usually the way we do that. A lot of times people will set this outside of the for loop because it makes it a little bit cleaner, but I tend to set them inside. The next piece it takes is the condition, what it's evaluating against. It wants to know what condition we're going to check every iteration. Usually you use the initialize variable, right? So we go I is less than 8. Cool. So every single time we're going to check to see if I is less than 8. The last is an expression that you're going to execute every single iteration. Usually you're going to execute this on I. So in this scenario, we'll increment I. Okay? One thing you'll notice right off the bat that tends to catch people is this semicolon and this semicolon. Those semicolons are essentially saying this is a statement, and then that's a statement afterwards. Don't forget the semicolons. It blows up the for loop. You have to use them in the semicolon. There's no way around it. Okay? The other thing about these semicolons too, when it comes to the for loop, they cannot be substituted with commas. I've had a few students do that, substitute them with commas, and it causes the for loop to blow up. You can't put commas. It's not a list. They are 3 separated statements. Incidentally, for those of you that like to think outside the box a bit, these are 3 statements. That's all they are. Which means this initializer can be a function call, if you wanted it to be. This condition can be a function call that needs to return a Boolean. That's it. I don't care how you return the Boolean or what you've done to return the Boolean. You just need to get a Boolean in there. And then this is whatever you want to do, whatever expression you want to execute. So if you want to call a function that does some really serious mutations, you can. This for loop can be extremely powerful. It's really only limited to your imagination at that point. All right, so like I said, they're used primarily for fixed number of iterations. We're going to use one right now on step 20. We're going to write a for loop that adds 0 to 10 together. So we're going to say for let I equal 0. I like to initialize to 0. And what's my condition going to be? How many people say less than or equals to? How many people just say less than? Okay. It's less than or equals to 10 because we want to add 10. Right? If we say less than 10, it won't actually add 10. It'll stop at that point. And then I plus plus. And then we give it a block. Incidentally, these wonderful curly braces are actually optional. If you only add one line directly afterwards, you can just tab it in, add the line, and forget about the block around it. You can do the same thing with ifs, as long as it's a single expression. Okay? It only gives you mercy for one expression. I recommend adding the block because it makes it a lot more readable. It's easy to tell what you're trying to do. All right, so obviously we're going to say for loop value plus equals I. Each time it executes, it's just going to add I to the for loop. And if you did it like I did it, you should see that code spit out. Now, like I said, for loops are great when you're trying to iterate over data, especially if you know how many elements are in the data. And dot length basically means that we know how many elements are in our data, right? So because of that, we can use the standard for loop to iterate over arrays, but there is a much better loop for iterating over arrays. And that was introduced in ES5, and it's called for of. And what the for of loop does is it essentially takes the element from the array, stores it in a temporary throwaway variable, and makes it accessible to the block. Okay. The cool thing about that is you don't have to use length in order to count how many elements are in the array. It will just keep iterating until it's done. It's a shallow iteration. Okay, so that's important to understand. It's a shallow iteration, which means it will not recursively go through the array. It will not go through and say, oh, hey, this value is an array. I better iterate through it too. And oh, there's another one. I better iterate through it too. It will not recursively go through the array. There are libraries for that, though. If you're building a tree and you're trying to get a tree's worth of data, there are libraries that support that type of iteration. However, this is not one of them. So we can do for of. If you see here, it says write a for loop that adds 0 to 10 together. I've given you an array that already adds all the values, that gives you all the values that you need to add together. And the way we write this array, the way that we write this loop is for. We give it an initializer. So I'm going to say let, and you can call it whatever you want, the initialized variable that you're using as your temporary variable. I tend to call it L. I don't know why, just probably because of element, right? Some people use item, whatever you want, right? Then the keyword of, and then the name of your array. And what's the name of our array? XR, right? XR. So what that's going to do is it's going to move to the first element of our array. It's going to take its value and store it in L. Then that becomes available to us inside our block. So in here we now have L, and L's value is currently 1, right? So I can say for of loop value. Make sure you write the right variable name down. It's for of loop value, not for loop value, right? There's two. Plus equals L. And if you did it correctly and refresh, you should see your code there with your for of loop. There's another for loop as well called for in. The for in is explicitly for objects. It's made to iterate over the keys of an object. Okay? We will be looking at that not next week, the following week, so week 4. Just a note, this is not the only way to iterate over an array. We could use that standard for loop if we wanted to. And the way we would do that, this is totally optional. You can write this if you want. First, we're just going to reset this variable back to 0. And then I'm going to say for let I equals 0. If I is less than, and I'm going to say, actually I think I have to do less than or equals to.
No, you can do exr.length.
Yeah, maybe it's just exr.length then, yeah. Dot length. Oh, right, because I'm starting at 0, right? So if I is less than exr.length, I plus plus. Right, of course I'm starting at 0 because it's easier to index off 0. Then I can just do for of loop value plus equals exr, and I'm going to pass I into its index. And the reason why I'm passing I into the index reference is because it's my variable. And each iteration, I is going to contain the index number of the next element in our array. Right? So the first time I go through, I is what value?
0.
Right. So exr0 is equal to what? 1. Yeah, exactly. Next time I go through, I will be 1. exr1 is equal to 2, and I just keep adding through. I mean, this is much more readable. Much easier, clearer to see what's going on than trying to figure out what this is doing, right? Incidentally, this is 2 of probably about 10 different ways to iterate through arrays. We also have a bunch of methods available to us that we're not going to talk about today, but we will be talking about when we take a look at object methods and properties, that we can use to actually iterate through arrays. And they're known as iterators. And the way they work is we basically call the array on them, and they pass the element immediately into the array. So just as a hint, and not to confuse, I'll show you the most common one of them. I'm going to take int r and do it with int r. Zoom in a little bit so you can see a little better. We use for each. For each is going to take something called a callback, which is actually a function. It's an anonymous function. I pass it the function. The function takes an argument, which, believe it or not, is actually each element inside my array. And I pass that in. Then inside here, I can go ahead and accumulate whatever I want to accumulate, but I'm just going to spit them out. And then I close the anonymous function. I close the function call, and I end everything in a semicolon. And as you can see, there's all my array elements that get spit out. There's a whole whack of these. There's for each, there's flat, there's reduce, there's map, there's tons of them that we'll actually take a look at in a couple of weeks. Okay? Just keep them in your mind. That's all I have. I don't have anything else. Take that main.js file, go ahead and fire that up to lab 2, and you're done. You've got no homework, right? Except for the quiz. Feel free. I'm here for the next 35 minutes anyways. Feel free to do the quiz. It's open and available to you. They close out at midnight tomorrow, right? So don't forget that. And that's it. Next week, I'll assign out the assignment. So if anybody's watching this YouTube video and isn't here, you may want to show up just for at least the beginning of class. Allow me to spit out what the assignment's going to be, and then you can go home or do whatever you're going to do. But yeah, just keep that in mind. I'll put out the assignment next week. I'm just curious. I think I might make it a group How many people are for a group assignment? Like, I mean, it'll be the same amount for one person as it would be for two people. Yeah? That's cool. Not many people are actually for group assignments. It's kind of interesting. Yeah, for group. Okay, cool. Then I'll just make them individual. That's totally fine. Yep, that's cool. Anyways, cheers.